I'm Dipankar Ghosh, CEO of DG2O, and our vision is to help businesses innovate and attain sustainable and profitable growth through the use of digital technologies. Now, I welcome you all to this seminar, which Soumitra has so brilliantly started and handed over to me, and making my life much easier on something called the digital technologies and Industry 4.0, which we are calling as the imperative of the post-COVID world. Now, what is actually Industry 4.0? Now, without digital technologies, Industry 4.0 is not possible. Industry 4.0 can be considered as the outcome of the use of digital technologies. So my focus will be to work on digital technologies today and present to you specifically Industrial IoT as one of the major digital technologies that form the backbone of Industry 4.0. All the other things that Soumitra said, things like robotic process automation, AR and VR, and data analytics, all of these stand over the shoulder of Industrial IoT. Without the backbone of Industrial IoT, you can't have all of the stuff. So it is very important for us to understand Industrial IoT because it is absolutely foundational. Now today I will cover, so even before I say what I will cover, I would like to bring some context to this, a topical context with regard to the pandemic, and see what some of these biggies are saying. We listen to all of these wise people from McKinsey, PricewaterhouseCoopers, and Ernst & Young. And they are all saying that the COVID pandemic has actually, fast forwarded the use of digital technologies in order to, solve some of the problems that we are going to face when we wake up from this pandemic and face a new normal. As you can see, McKinsey is saying that business digital adoption in a matter of 8 weeks. So 5 years have been fast forwarded to 8 weeks. That's what they're saying. It could be a bit of an exaggeration, but it's important to know that. PwC is saying that tremendous acceleration in digital transformation of global economy. And EY is saying that accelerated digital transformation across the world is going on at the moment because of the pandemic. Now let's see what some of the big corporations are doing. As you can see, we have on the left, there is a big news about TCS saying that about 75% of their workforce will start working in 2025 from home. And that's a big change. They have been working on something called the SBWS, which means that secure borderless workspaces, which is an amalgamation of several digital technologies to make safe work from home, in the sense that you do not get to lose data. At the same time, you are cyber secure, which is a very important thing that Soumitra had pointed out, and you are able to be assured that you will get good results even when people work from home. So this is what TCS has been doing, and they are now reaping the benefit during the COVID pandemic because they have been working on this kind of technology for the last several years. Here is a news report which came up at the end of April after the lockdown happened, and this particularly says that the Barmer Rajasthan plant of KN Energy have utilized only 20% of their workforce on the ground in the factory to produce 80% of the output, while the rest were working from home. And that is because for the last couple of years, they have been investing in automation. And that's a very big change. And as you can see, the COVID pandemic has actually accelerated that from happening. Apollo Tyres is saying that they are no longer going to be able to, at least in the recent future, in the near future, be able to use trade shows and other events to showcase their product launches. So they are going to take the virtual route in order to do that. Dr. Reddy's Laboratories also is saying the same thing. They are saying that they are not able to send their medical representatives to the doctors. And until then, they have rapidly ramped up their digital channels and virtual channels in order to be in touch with doctors and other stakeholders like vendors and suppliers. So as you can see, the big people are already, taking digital initiatives in a very fast way forward. So let us have a peek on today's program a bit. I will cover, the digital technology part of it based on the metaphor of this three-legged stool. One leg is the business, the third is technology, and the second is technology, and the third is you personally. And all of these legs has a seat, which I call governance. Now, I'll be going through all of this quite fast because of the limited time that we have. However, let me assure you, as Shomita was telling you, that we have separate courses on each of these areas where we go much deeper into it. However, what I would like to request you is to take notes, and so that you can put questions across during the Q&A session, and we'll try our best to fill up the gaps that may be there. So now let's starting from the business side of things. What indeed is digital? Now, digital is something that we have been hearing for a long time, and it's all in the years now. And but are they within in front of our eyes? Of course they are. But however, we may not be realizing that. Take for an example, this girl who is my niece and who is in school. She likes to write poetry, and she likes to also show her poetry to the world. All she does is use a free app on a mobile to write the poetry and come up with such beautiful postal-like outputs, and then publish them in WhatsApp, Facebook, Instagram, and boom, she becomes a published poet. In my times, one had to write on a longhand in one's notebook, then wait for the school magazine to agree to print it, and then hope that the school and the friends and family would read it. My friends, we have come a long way from those days, and this is what digital is. As I said, digital is all around us, and we are very familiar with all of this. Now, what are the characteristics of digital? I call them the 3 Ds of digital. The 3 Ds of D. Firstly, it has a lot of data, and digital produces data in order to help you to make superior decisions. Then there's something called disintermediation. Digital produces disintermediation, which is nothing but a very complex word for meaning that you cut out the middleman from the equation and deal directly with the stakeholders. And lastly, the most abused word of the century, disruption, which of course we cannot ignore. Digital is supposed to and brings disruption. And what does disruption mean? Disruption means that you go and do your business in a way that is totally different from what you're doing now. So, for instance, the Ubers of the world, or the Airbnb of the world, or the Shadi.coms of the world have actually disrupted the old way of doing things, if you can look at it more closely. So always think about, if you are thinking about something digital and applying digital, you see whether you are actually using all of these. We're using data, you are ensuring that you are cutting out the middle person. For instance, in a factory setting, whether you can automate in such a way that you remove the worker from there, and the worker only monitors periodically. So that is, in a factory setting, cutting out the middleman. Okay, here is some interesting fact in context. Over the presentation, I will have several such facts in context when I take a pause and you do all the hard work of reading it so that I can have a glass of water, for instance. Hope you found the pause over. Hope you found that fact to be useful. Let's go on next to the next slide as to why digital. Now, why digital? Because of some strategic compulsions, such as making business sustainable, creating new business models and revenue models, fueling innovation, and creating more value for the customer. Please note that several of the Fortune 500 companies or even Fortune 50 companies which existed 10 years back are no longer there, and new companies have come across to replace them, all because they had not been able to make their businesses sustainable. For instance, a company like Kodak. Okay, I'll not go into the details, but just to give you an example. So there are strategic compulsions to make a decision about digital. Then there are tactical necessities, such as you need to go to the market more faster. You need to increase your production and productivity. You need to make your workforce safe by perhaps giving them remote possibilities of working, making your workforce collaborate even if they're across the world, become more predictive rather than reactive, enhance quality. So all of these are survival and growth factors which constitute the reason why that we need to go for digital. How do we do it? We do it by using data as the primary capital. Data is the new oil, or data is the new currency, or whatever, or data is the new gold, or whatever you might want to call it. But at the end, it is true, and only those who become the most valuable information provider to their customers will win the war. It is not who gives the best car or who gives the best camera or whatever. It is the person who is going to provide the most valuable information. That is the person who is going to win. And the what is basically digital, and digital is the instrument through which you achieve all of this. You achieve the ability to get data and use the data and make it valuable for your customers to do all that you wanted to do with regard to strategic compulsions and tactical necessities. Now, I will take an example of a company called John Deere, which is a global farm equipment manufacturer. Their principal customers are farmers as well as equipment owners who rent out their equipment to the farming community. They have built an extremely valuable service model around their products, which they call as the myjohndeere.com. It's a portal and a platform to which a farmer can log in and get a variety of information to manage his farm and farming activity. For instance, if I'm a farmer and I have to harvest today about 100 acres of land, and I log in and I find from myjohndeere.com that the weather is going to be bad, is going to rain heavily in the afternoon, then my time to harvest my field is limited. Now, having got this information, I quickly can search and find out from this portal as to whether I have the capacity to do that within that limited time. If I find that I do not have the capacity, I can get in touch with my equipment supplier, the guy who has bought the equipment from John Deere and is supplying to me, and he's actually renting it to me. That guy also logs into his myjohndeere.com, and he finds that he does have a couple of more harvesters that he can lend me today. And he sends that to me, and I'm able to do my job in quick time to avoid the rain that I'm expecting in the afternoon. Now, how good this is for me as a farmer to receive this kind of information just on my tab or my phone or my laptop and at an instance. So what can it do for the farmer? It actually can do a lot. As you can see, we have machine operation, machine condition, everything that goes into the machine. In fact, I'm able to even track when my machine requires repairing. I can even order spares. I can find out whether spares are available or not. I can manage my fleet. On the other side, I can understand the weather condition. I can understand the soil condition. And on the third side, I can collaborate. I can collaborate with my, for instance, I collaborated with my equipment supplier to, help me to get more equipment to do my work within the given time. I can collaborate with my colleagues also. It helps me to plan. It helps me to do performance analysis of all kinds. So that's the power of, digital technology. And all of this, mind you, has a relationship with industrial IoT because, what they have done is to use IoT sensors on the fields, on the machines, on the components, and have used communication technologies to bring it onto the platform on your phone or tab to give you this information. So that is the power of industrial IoT. Now, here are some terms which, due to the, in the interest of time, I will not go through, but digitization and digitalization, automation and automation, operational technology and information technology, these are very important terms. And some other like digital transformation and Internet of Things, these are very foundational terms that one must understand in order to understand Industry 4.0 and Industrial IoT. But now, for now, I will assume that you all know about these terms and I'll not go into the detail and skip this. However, if you have any questions, we can always answer them at the Q&A session or even later. Okay, now it's breathing time for me and you can read stuff. So what this said, even before I move to the next slide, is, Kevin Ashton, Shomita talked about 1999, he coined the term IoT, and what he basically says that, computers do a better job in entering data into their logical systems. So it's better to leave it to them to take the data in directly rather than using human to do that. And that's what IoT is all about. Now, let's understand why businesses implement IoT. This was a survey done last year by PwC. And as you can see, there are several reasons. And only 4% of people are saying that they're going to implement IoT in order to save money by doing things faster and more efficiently. But others, changing business model, redefine company, break into new markets or industries, modernized brand with new capabilities are all about making money. So now people are thinking about, rather than saving money, they are now thinking about using IoT to make more money. A bit dated study, perhaps a couple of years back, things were a bit different, where 54% were saying that they wanted to save money, 35% were saying that they wanted to make more money, and 24% were saying that I want to use it for safety reasons as well. What I'm trying to say here is that all of these are very, very valid reasons in order for businesses to implement IoT. Where does the most value lies? Now, several studies, I'm giving a study from McKinsey in 2015, but I have seen other studies as well. They clearly point out that it is the factories which will have the most value, meaning that it is the factories that will be using and implementing and buying stuff for IoT and implementing IoT more than anybody else, such as smart cities or health or retail or even vehicles. Vehicles come quite at the bottom. That's something which I'm particularly interested in, but vehicles are actually at the bottom while factories are at the top. And there are trillions of dollars of value that is going to be created. Now, I had a few slides on enablers. I have hidden them. What are enabling the process of quick adoption of IoT, industrial IoT? But I will leave you with this slide to ponder over and you might get an answer. So people having mobile phones number more than people having proper sanitation. So that could be one of the major answers as to why people are going digital. Let's look at some of the challenges because they prevent us from progressing and succeeding. What are the constraints? Executive commitment is one of the major constraints where executive management, the senior management, the board do not commit to make changes because IoT and Industry 4.0 require you to make heavy changes. Why? Because perhaps they have a knowledge gap, and that's why we have these kind of webinars and courses. They are risk averse. They don't want to take a risk. They think that because they are, wallowing in past success, and perhaps they don't face any competition. So that's a major bottleneck. Now, the next is change resistance. Even if the executive management is committed, people down the line, if they are not, buying in, then also you have a problem. And the reason for that is that people have fear of the unknown. They have lack of awareness of what these new things are. And they live in the comfort zone of doing the same way every day. So they don't want to do anything new. Skill gaps. That's a big one because all of these new technologies are changing very fast and they are not matured. Some of them are not matured also, as you can see in the next one. So it requires people to get themselves updated very quickly. And in the workforce, in most of the older kind of industries such as mines and energy and even heavy industry, automobile even, people are quite senior in age. And for them to be able to, grasp new technology can be a difficulty. And they may be threatened with the young guys that come in who are more smart in these areas. Next is tech maturity, where some of the technologies are yet to get mature and become more affordable. And finally, as Shomita had pointed out, cybersecurity is a major, major issue. Let's look at some of a very interesting report that Dell had come out, Barriers to Digital Progress, and it's a comparison between 2016 and 18. And there are 13 barriers exactly measured in 2016 as in 2018, but things have moved, as you can see. Some of the important things that I can see are moving is that one was lack of coherent digital strategy and vision, which was number 7. Now it has become number 9, which is very heartening. Then lack of senior support and sponsorship. It was number 3. Now it has become number 8. These are quite significant shifts within only just 2 years. Of course, there's an interesting thing that, for instance, data privacy and security, which is we are talking about, definitely. Just a moment, there's some call coming. Okay, sorry. Cybersecurity has moved from number 5 to number 1, which it has to, as we will come and cover later. So that's a very interesting shift, which means that this technology is actually gaining traction in business. Okay, that finishes my business part. Now I will run through the technologies that go into the industrial IoT backbone for Industry 4.0. Now, we cannot think of Industry 4.0 without industrial IoT, as I had already mentioned, because that forms the backbone. Let me use the metaphor of mobility. In pre-industrial age, the mobility is somewhat like this, as you can see. Now, as we enter the industrial age in the late 1800s and early 1900s, we have the automobile, which is powered by the internal combustion engine, which is fantastic. It reduces a lot of human and horsepower effort, although that horsepower had now been put into the IC engine. Then in the 1980s, we enter the modern age when the automobile has a lot of sensors and onboard computers to make life a lot easier for the person who is using the automobile. And this modern age continues to this day, where of course we have improved things, we have improved the sensors, we have put more number of sensors and stuff like that. but we are still in that modern age. But here, we are already entering the digital age. So there is some overlap. While we are still in the modern age, we have entered the digital age. And now we have this computer, a very large computer which has 4 wheels, looks very nice, and you can actually ride it, but it's actually a computer, but it looks like a car. And you might mistake it to be a car, but actually it's a computer. It's a large computer. It has more lines of codes than perhaps some of the more sophisticated ERP systems. So Soumitra has already discussed this ride to today. We had written from Industry 1.0 to 4.0. I'll not go into the detail, but let me tell you that today we are trying to enter into Industry 4.0 area with cyber physical systems, which is very similar to that Tesla car that you saw, whereby we are trying to say that factory will actually be a giant computer, a very big computer, and it will not be called a factory. It should actually be seen as a computer system. Now, we need to understand a bit about the difference and the leap that we have to make from 3.0 to 4.0. The reason being, as I said, we are still into 3.0, and it will take several years from now to be truly Industry 4.0, because there are a lot of things have to come. We have to discard old things, we have to adopt new things, the technology has to mature, we have to find the money to do it, and we have to do a lot of things, we have to learn things. So there's a lot of difference between 3.0 and 4.0, and it's all in this slide. However, I will tell you the principal difference is that in 3.0, the factory was, the factory automation and the data was concentrated and localized into a machine or a group of machines. And in Industry 4.0, we are trying to make it all distributed, meaning that there will be a total connectivity across the value chain of the business. In fact, it will allow, and therefore data will move from one point of the value chain to another in a very seamless fashion. So, and the value chain also means that your vendors, your supply chain, you should be able to track where your material is at the moment. You should be able to track even where, if you have given a vendor something to do, where his output is, so that you know that when you're going to get him. And all of this is going to be happen seamlessly, not trying to log into a system and trying to find things out, because some of those things are still happening using the ERP system. And that can happen only when machines and devices talk to each other, and they talk to people as well, and also the IT systems. Now, the Germans in the Hannover Messe in 2011 mooted the idea of Industry 4.0. They were the first guys, and they said that there will be 4 design principles of Industry 4.0. Interoperability, which means that machines will communicate with machines and people through the internet. Then there will be transparency of information through virtualization, so people can see what they need to see very easily. Technical assistance should be there, and which should support decision making and reduce human efforts. And there will be decentralization of decision making process. So these 4 design principles underpin the Industry 4.0 concept. So if your Industry 4.0 initiative does not have any of these principles, then it's not actually Industry 4.0. So please keep that in mind. Now, this is the IoT band, which we consider as sort of, we have segregated some of these things into consumer, semi-industrial, and industrial IoT. You can have a look at that. And this segregation is not tight, and obviously there are some overlaps. For instance, we're talking about wearables in the consumer IoT, but wearables are also being used by people in the factories to give a lot of information regarding the operator health and safety things and all that stuff. So there is a lot of overlap. But for us, hardcore industrial IoT is manufacturing, mining, oil and gas, etc. Now let's see how through this schema, how the industrial IoT ecosystem works. And going back to the John Deere example, I've come up with this schema where I can show you that the John Deere has all of these machines, and these machines can be equivalent to what you call the factory, and they have components and systems like hydraulics and brakes and things like that, engines, tires, and each of these have some sensors, etc. All of these sensors are then in some way connected to either an onboard diagnostic connector, something like this, or directly, if they're not connected to this connector, they're connected to some kind of a data acquisition and gateway device. So all the information that is, for instance, a tire pressure or a temperature within oil in the hydraulic system, or the pressure that comes, goes here, goes to the device, and the device processes that data and uses the gateway to transport the data to the cloud servers. And in the cloud servers, you run algorithms and even AI or ML models in order to give you useful information on a real-time basis, and you can see that on your on a handheld device itself. So things like fault diagnosis, asset utilization, maintenance planning, operator behavior as well, fuel level, tire pressure, speed. These are things that on a real-time basis are available with you. So here's another example, a kind of a virtual example where I show that an architecture where within the manufacturing process there is, there is an input and an output to the manufacturing process. The manufacturing process has sensors and actuators, and they use the network communication to transport data to a software hardware platform, which has compute resources and storage. And that software is connected and sends data to higher level software applications, depending on who wants to use that application. So there could be a data manager who uses his own application, logistics guy uses his own, and things like that. So data goes there. And then based on certain rules and recommendations, there could be some triggers of data coming down, and and actuators can be actuated in order to make some decision changes, changes in the manufacturing process to either speed up or to slow down or to completely stop and things like that. And that is how the cycle goes. Now, data also could be transferred to a distant cloud where you can have an AI ML engine or analytics services of both, and which will have somewhat similar architecture in order to do more deep diving into the data to give you more intelligence for better decision making. Here I can show you, I'm trying to show you that this is where the operation technology, where actuators and sensors are there, are meeting information technology. And OT and IT, when they meet together, that is when Industrial IoT and Industry 4.0 happens. Note that the representations that I've shown about the architectures, they're not set in stone, and it is possible that there are many other kinds of ways, but this is a very kind of a conceptual thing, which is very generic, and it helps you to understand how the entire system is architected, right from sensors to your palm handheld where you see the information. Now let's look at the key components of an IoT system. So there's a data emitter, there's a data capturer, which is the data emitter is the equipment, the data capturer, the sensors, then you have the data manipulator, which is a device, and a gateway perhaps all together, or you can have a gateway which is separate, and this is nothing but an embedded system. And then you have the communication network going to the servers, which runs the platform, and through the platform and the application you get to see the data. We'll quickly run through each of these so that we don't spend too much time, because we have detailed courses on all of these sensors. I've chosen the phone, the smartphone, as an example because it has a lot of sensors, such as the accelerometer, the gyroscope, the microphone, the camera, the GPS tracker, the light sensor, for instance, the distance sensor. So all of these sensors are there in the our smartphone, which we may not be much aware of. And using this sensor ecosystem within the iPhone, a lot of IoT developers are developing apps to help you with personal safety, to track your mental mental and physical health, and also help you to run your home appliances and home automation systems. Similarly, smart wearables, which have a lot of sensors embedded into them, it can help you to track your health and activity data and send them to the cloud and even to your health provider as well. All because there are sensors there. Embedded systems. So these are some of the examples of an embedded system. The automobile has perhaps nowadays some of the high-end automobiles have more than 100 of such embedded appliances put into them for doing various activities and giving various types of data. Now, the definition of an embedded system is such as this. It is embedded because it's a part of a larger system and a device. It is a system because it is a computer by itself. Like a computer, it has a processor, it has memory, it has an input-output ports, it has program, and it has data. It is dedicated because it is special purpose and performs only specific functions. And it is expected to work independently without any human intervention. And it is supposed to act and respond to certain situations based on what the sensor senses and what the actuator tells him to do. Compare this, whatever I have told you, with, for instance, a washing machine. You will find that the washing machine's microcontroller has all these characteristics. It is embedded into that. And the washing machine itself is a big appliance, and it has program and things like that. And it is specifically designed to ensure that the washing machine has a running cycle according to the washing machine. You cannot use it for running a microwave oven, in fact. And it is independent because you don't have to go there and every time put some buttons and all. When you're started, it works on its own, and it responds because it runs different cycles. It gives different temperatures. Then it spins and then it stops. So as you can see from the example of the washing machine, how an embedded system works. Okay, these are some of the characteristics of the embedded system. I'll not go through them all. However, two important things I must tell you, that they must have low manufacturing cost because they are, or rather I'll tell three things. Low manufacturing cost because they are part of a bigger system. If they have large manufacturing cost, then the system also becomes very expensive. They need to have low power consumption because most of these will not run on power. In washing machine, at least they have power, but most of them will run in the remote areas and they will run on battery. And the last thing, which is important and I will cover also, is real-time. Most of them are real-time operation, meaning that they are deadline oriented. They are strict deadlines for job completion. So that's what real-time systems mean. There are two types: hard real-time, soft real-time. Now, hard real-time is if the deadline is not met, there can be a disaster. For instance, a nuclear reactor or an automobile engine or a flight control or even say a pacemaker. So these are very hard real-time, and so the design factors are more stringent. Soft real-time systems are like your personal computer or say a video, Netflix or Amazon, which Sumitra was talking about. If there is some delay, you only have some kind of a degraded performance, but it is not disastrous. This is a generic computer architecture stack, and I'm not going to go through this. We have detailed courses on this, as I said. However, the reason I put it there is that you, as a technologist, must understand the computer architecture stack well in order to understand what the embedded system does. Because an embedded system is also having a similar stack, very similar to what your laptop has. Here is a simplified embedded architecture. Again, I'm not going to through this completely. Again, it's very similar to your computers. And we will cover all of this in great detail when we have our course. One of my colleagues, Kumar, is already here. He has a course on embedded architecture. So we'll come back with that on that. So that was a long one. So I deserve a break. You do the hard work. Network communications, the next part of it. Okay, very quickly, we have things like personal area network. The personal area network is, all this PAN, LAN, MAN, and WAN are based on the proximity of the devices. So personal area network, as it certainly means that the devices are in very close proximity and they can be connected to each other either through we do that in our houses or a small office, for instance, using Wi-Fi as an example, or it can be even a wired office as well. But it is a small network within the office, nothing goes out of it unless you have an external router to do that. Then we have the LAN, which is a local area network. These are used by large offices. The connections could be, Wi-Fi, wireless and wired as well. And they may have, connection with the internet. But these are for large offices where each system is connected to each other in some way, through a cable network or through a wireless network. Then we have the metropolitan network, area network, where usually used by local municipalities and similar such organizations, where they connect their offices and other customer offices through a system like this within the metropolitan area. Then we have the wide area network. The wide area network connects offices from geographically distributed area. It can be within the outside the city, outside the state, and sometimes even outside the country as well. So that is based on the proximity. Now here is something called the BAN or the M-band, which is the medical band. You have the body area network. Now the body area network is nothing but we have looked at the wearables where you have sensors, and it helps you to use your mobile phone to get data and then use the mobile phone to transport it to the internet and into the servers to help your caregivers and your health specialists, your doctors, to track and perhaps even help you if you are in an emergency. It's absolutely great, and this is something which is very interesting to know, that there's something called the BAN or the M-band. Now, here is something called the communication protocols. It's through the communication protocols the data moves, and there are dozens of such protocols. I will not go again on detail, and we may have another course, especially on the communication protocol, but we need to understand something about it. So the communication protocol allows the data that has been produced in the device or in the sensors to move from the device and the sensor to other places, from device to device, or device to a gateway device, or from device directly to a cloud server, or from the gateway to the cloud server. All of these require some kind of protocol to transfer the data. So here things are like this, it also shows the ranges and the kind of frequencies of each of these. For instance, the near field communication, NFC, is a very interesting thing which we have all in the phone, at least in the modern phones, which helps you to transfer money from your account to the buyer's account using by tapping on the surface. So you can tap the mobile phone on the surface of the POS in a retail, and your money flows from you to your account to that account. It uses NFC. Very interesting. All of these RFID we all know, and I'm not going to go into detail. So all of these are short-range protocols, which are used because of the fact that these devices are power hungry. All of these can be very power hungry stuff. However, you do not have enough power. They run on batteries, and therefore you need to conserve power, and that's one of the primary reasons why we have these short-range protocols. But they do not move large distances. Then there are protocols which move slightly larger distances, such as the Wi-Fi. Then of course you have the 2G, 3G, the LTE, 4G, and 5G, etc. And then you have the long-range ones, which are things like NB-IoT, LoRaWAN, Sigfox, Ingenu, and all. So the idea is that when one thing before I move from here, all these things use radio frequencies. They are all wireless, and the radio frequencies, the higher the frequency, the shorter the range. The lower the frequency, the wavelength is more, and you get more range. And however, they become more weak as well. So we can deal with this later when we delve deeper into an independent course on this. So field to cloud protocols and connections. This is an example how things can move from the field. Just because I showed you that John Deere example, John Deere would have used something like this, where you have sensors here which sends data through some of these short-range protocols, high-frequency short-range protocols to your gateway, and the gateway uses long-range protocols using perhaps your Wi-Fi or the GSM network to send it to the company cloud. And this is a third-party cloud, something similar to the weather stations, because weather stations would be third-party supplier. So this is just an example that I wanted to show you with regard to protocols. Then IoT platforms. We talked about IoT platform in this slide, if you remember. So moving on, why do we need IoT platforms? One of the things that there are a variety of sensors working with a variety of protocols and different types of standards and all. And there's a lot of complexity happening at the base level, which is the hardware level. And there are a lot of interoperability issues as well because of the fact that there are a variety of devices, variety of protocols, variety of standards, etc., etc. When you use an IoT platform, it helps you to get, totally, hidden from the problems of these kind of complexity and interoperability. So you're not bothered when you use the IoT platform, the IoT platform takes care of it. You do not have to bother about it. Then there are, hundreds and thousands of devices, suppose in the network. For instance, the John Deere network would have perhaps many thousands of devices because not only I am the farmer, there are hundreds of other farmers. There are hundreds of other equipment. So they need to be, all of these devices need to be managed. When they come to their network, when they get bad, everything needs to be understood. Similarly, there is a network. The network also needs to be managed in terms of performance and routing and stuff like that. So the platform helps you to do the device management and the network management. Similarly, you can easily build, if you have a platform like that, you can easily build custom-based software over and above that without thinking of all of these complexities. And you can also integrate third-party applications like ERP or SCM or things like that. Then you have big data analytics and AI and ML engines all integrated in the platform. So you don't have to think of those. You can directly use them. So you don't have to build your own. And finally, the platform takes care of the security as well, so that you don't have to build your own security walls. So it's good to, if you can build your own platform, but my advice is that you should actually use an existing platform because building your platform takes years, unless you are going to compete with some of the bigger ones that I can show you. So it's a good investment to invest on a platform. And without a platform, you can't run a good Internet of Things system. So this is some of a list of 25 best IoT platforms based on in 2019 based on customer satisfaction, and we can see Amazon AWS, Microsoft Azure, and Google Cloud as at the top. So we have traveled far since the days of Apollo 11. And that's an interesting fact. I'll show you now two examples because people love to see examples and not want to listen to theories. So this is so we talked about wearables, where we are wearing wearables with a lot of sensors and all, but here is a machine wearable. The machine wearable is nothing but a sensor with the ability to transmit data and then fixed into a vacuum pump, for instance. And this sensor is actually, tracking 7 parameters, things like belt tension, blower temperature, oil level, and things like that. And each of them are giving real-time data. And as you can see, there's a graph, and the graph shows a green zone, an amber zone, and a red zone. If something moves into a red zone, in this case, I think it's vibration that is moved into the red zone, then you get an alarm, and you can actually see what's going on by clicking, and you can drill down and see a lot of reports such as this. In fact, in one of the cases, they found that the filter was having some problems, and they were able to hit the button to find out details, and it says that in zone 1 pump on such and such a day, the filter clogging has been done. So you have to, the preventing action is clean filter. And if you do not clean filter within another 23 days, this is going to get into a red zone. So this is the power of IoT. When you get data and on a real-time basis, you analyze them, you can give this kind of information where you can really say that within 23 days, your filter is going to get blocked, and therefore please change it now. And if it gets blocked, maybe the pump will get damaged. So there's another example. This is something that we have done. So I'm proud to show it. It's one of our devices which we call DIDA. And this is being used by a company which runs an automotive HVAC system, and it is connected to the filter of the HVAC system. And as we can see, there's a filter clogging effect, and we are measuring the differential pressure. So this differential pressure increases either with the speed of the blower. When you move the switch of the AC from the minimum to maximum, and the differential pressure will increase, and that's a normal increase. However, if you have a clean filter, the differential pressure is less. A moderately dirty filter, the differential pressure is more, and a very dirty filter, the differential pressure is still more. And now we can correlate with the pressure and the dirtiness of the filter and use some image processing methods, which is going to be our next step, to give a solution to the filter manufacturer and see whether that solution helps them to make better filters, design better filters. IoT security, a very, very important area, and a very subject that is very close to my heart, because most of the horror stories that you hear about IoT security are very similar to the thrillers that Soumitra talked about when he looks into Netflix and all. I like thrillers as well, so all of these are very interesting things to look at. But seriously speaking, IoT security, although this comes almost last in this discussion, it is the first thing that you must think of when you are designing a solution, not as an afterthought. The solution ban gaya, and then only we think, oh, abhi security dalna hai uske andar. Nahin. So some of the security horror stories. Here is a casino in the US which was hacked, and its very secure servers were hacked through a thermostat that was connected to the internet, or not the internet, their network, and that thermostat was dipped into their aquarium, and a lot of sensitive data was hacked by the hackers. Here is a story where a hacker stormed into the baby monitoring device based on Nest, the Nest, Google's Nest device, and they threatened the parents. The guy who hacked actually started threatening the parents by hacking into the device, because there's a Wi-Fi camera there, which helps them to monitor the baby. And that guy hacked into the camera and was able to see the baby. They were able to see the bedroom and things like that, and was able to even speak to them and terrorize them. Now, Target, which is a retail store, their HVAC system were connected to the internet, and that got hacked and resulted in a lot of client and financial data being compromised. So that was a big one. And our own Kudankulam nuclear power plant down south, it got hacked last September twice. Now, thankfully, nothing much happened. It was a two-stage attack. In the first stage attack, they found out the details about the server and all, and how to enter the server. In the second stage attack, they created a malware where they hard-coded the information and put it into that. Through it perhaps happened, nobody knows how it happened, because they did not come out clearly on that. And it went into the network. Thankfully, it was only for gathering data and not doing any destructive action. But please note that hackers can even destroy things and can cause havoc. And you can understand what kind of havoc can happen when a nuclear power plant gets destroyed. So this is the information security stands on three legs or three pillars. Confidentiality, which is limiting the right of information to only the people who need to know and nobody else should know. So you should be able to create a system where you are able to build on confidentiality. Similarly, integrity. So the information that you see must be trustworthy and accurate, and there should not be any ability from some external unauthorized party to change that information or delete the information or take the information completely out of the system. For instance, if you have 20 lakh in the bank, nobody should come there and make it 25 lakh, which will make you happy, but that is not what should happen. Or nobody should take the money out and you have zero. So that is one. And then there's something called non-repudiation, which is very important. when you enter the information, you should not be able to say that, no, ye mera information nahi hai. It should be that kind of integrity. Then availability is a very important thing, that information should be accessible and by authorized person whenever they need it. It should not be that you're wanting the information, but the system is not working, the server is down, and database is down, and internet is not working. All of that is also part of information security. The information security chain in IoT has to be built across the devices, gateway, and communication line, which is basically the ether, the air, and in the cloud platform as well. And there are many ways to do this. I'm not going into the details. We'll perhaps have a separate session on information security. But what is important to know is that you must build a security mentality within the organization. Very, very important. When you start designing a system, you should design for security. You should manufacture the system for security. Very importantly, for instance, Seagate. Seagate makes all of these hard drives. It is all designed in the US because they have the brains there. Where they get manufactured? They get manufactured in China. And let me tell you, I was listening to one guy from Seagate. They said, we have designed it, but when the Chinese make it, what they put into it, I don't know. So what then finally comes to your laptop or your servers or your information equipment, we don't know. So manufacturing for security is also very important. So these are some of the areas that but one last thing that I want to talk about security is this, that most security breaches are inside a job. Either because people are ignorant, or people are careless, or they have malicious intent. So it is our duty to ensure that we have good people who are always trained on security and who always ensure security. I know that people, even sometimes in my organization, it has happened, people have put on the whiteboard the password or something so that everybody can see it. What ridiculous. So this is a very fearsome fact, as you can see. Let's move on. Now we move on to the third leg, which is you. People build organizations, people make things success. And if people do not set themselves up for success, then the organization is not a success. It's very same when you implement Industry 4.0 and Industrial IoT or any of these systems. So you have to be the central of entire thing. You are the center of the universe. You are the sun. You are the sun god. So what do we need? We need leadership, and some of you are leaders or will be leaders who have to have vision, knowledge. You have to be able to take a risk. You have to build good teams. You have to cut red tape, no bureaucracy, and you have to allow failures, because failures are going to happen if you're going to take up something new. You have to ensure that there are enough knowledge and skills that are required, and that's why we have these kind of seminars going on, where people right from the top and down to the bottom, they know about things like technology, business, data science and analytics, AI and ML, which are the very basic of getting the benefits out of Industry 4.0. Then there's a lot of investment that is going to take place. So you have to learn how to build a business case and evaluate the ROI. Don't jump into doing things without taking this step. Then you must have a method. The methodology you must follow, you must start big, think big, but you must start small, because if you start big, you might fail, and then it becomes a very cumbersome thing to manage. You must always keep the end in mind when you start. You must select projects based on high potential of success. If you succeed in one, then succeeding in the next one becomes more easy. In between, you must monitor and evaluate and see how things are going on. If you do not, then things can go wrong. And once you see that at a certain stage, when you see that things have worked out well, you scale up. You make it more broad. However, if things have not gone all right, at certain stage, you must abandon them. So now let us move into the second thing, this slide, where I'm talking about the leadership, because leaders are required to every day strategize on how to make more money. Now, as one of the videos that Shamita showed, one guy was saying that, now product, more than product, it is the service that has become important. And all of this data that is being captured help you to become, create as a service revenue models. Even products are now becoming services. Products are no longer going to be sold as products, but they are going to be sold as service, pay for use, for instance. Then you have something called the process as a service, anything as a service, data as a service. And data is ubiquitous and imperative to create the value across all of these services. If you look at the John Deere example, in detail and in deeply, you'll know that all of these are there. And I'm not going to detail that. You have to think about that yourself, and we can answer any questions later on. Skills in your team. These are the skills that you must have: sensor technology, electronics, embedded software, firmware, network communication. We have discussed all of this. Data science we have not discussed. We are going to have a separate course on that. However, Soumitra did touch about a lot on the data science area. Then software development. These are the skills, new skills which all factories have to think of to incorporate. I know companies where mechanical engineers at the very senior level are learning all this now because they know that they have to change. And I know that because one of them is our customer. People in the 50s or nearly 60s, director level people learning IoT, which is good. Now, as I said, we need to understand how to make the business case and evaluate them. Very important, don't jump into doing work without knowing whether they will be return on your investment. So these are some of the examples that, with some illustrative data, not exact data, that I'm showing in terms of what we have done for some of our customers. And we have done some exercises on how much money, our deliverables are going to save them. So these are the things that you need to learn how to do, and we can discuss this in more detail in a separate forum. But very important. Methodology. This is a methodology that we follow in DG2O. However, this is not very different from others. Understand the need, assess the status of what we have at the moment, come up with some plan, build prototype, and run pilot, monitor and measure how things are happening. Our job, as I said, to come to step 5 as quickly as possible. Our mantra is fail fast, learn faster. If things are not working out well, and we know this within say 3 months or 2 months or 1 month, then we can abandon it. No matter, and we can go to another project. But if we can linger on, then we can be a big failure. However, if it is the happy situation that things are working out well, now you start implementing in full scale, and then you can define a long-term strategy after that. So this is the methodology that we suggest, and others will be suggesting something very similar, I think. Now I come to governance or corporate conscience, which is the seat of the stool and which binds all the 3 legs together. The only thing that I have to say here, there are a lot of other things to say, but one of the things I must say here is that as leaders, we have the responsibility of protecting our people from harmful consequences or disaster consequences of information technology, in technology in general. Let me tell you, IoT or Industry 4.0 is no different. There are a lot of unfortunate consequences of introducing this kind of technology, unfortunately, and we cannot ignore them. Things like, occupational stress, the need to be keeping up with the new technologies, especially for people who are past their, learning capabilities, perhaps slightly senior. And, these kind of technologies also bring a lot of transparency, and therefore the accountability increases, meaning that you cannot take a break. People may be after you, and there's a lot of privacy and liberty issues as well. All of this can lead to some disastrous consequences with regard to mental and physical health. Privacy and liberty, as I said, can also be compromised and can be a reason for people getting mentally sick as well and not being good performance. So these are the unfortunate consequences of technology, and it is our job to alleviate the pain as much as possible, although we may not be able to do it completely. So, I call it the 4 E's. In the 4 E's of lessening the pain, we must engage and communicate on a regular basis with our people to make them understand what's going on, why they're going on. We must empathize with them, with their systems. Sometimes there will be job losses, for instance. Therefore, that needs to be taken care of. We should treat them with equity and fairness. People should understand that there has been fairness in when they deal, and of course, they're quite generic, but these become, I assume, more important in such a situation. And lastly and finally, and very importantly, our job is to give a lot of encouragement to our people to keep themselves developing and reskilling throughout their life, whether they are within the organization. You build the DNA of learning constantly, because that is absolutely imperative to be successful in the future. Because in 2 years from now, in 5 years from now, what you have learned today is going to be useless, most of it. In the closing, so as I close, I need to summarize and see, just in case you fell asleep while I was doing all of this monologue. I don't know whether you guys are still there, but I'm still going away, talking away. So what I covered was, in the business aspect, the what, the why, and the how. Then we went through a journey of the journey of technical building blocks of Industry 4.0, mainly IoT, which is sensors, embedded system, network and communication, platforms, and IoT security. Then we dealt with the people factor, where we talked about leadership and what they need to do, the skills that they need to imbibe and incorporate within their entire ecosystem, the business cases that they need to develop, and the ROI that they need to evaluate in order to put money where they want to put the money, and the methodology that they need to follow. Then we talked about the governance part of it, which is organization conscience, and the 4 E's to alleviate the pain. And finally, I could not find any better I couldn't find better quote than this: never let a good crisis to go waste. Let me tell you that when we look back at history from the future, the COVID pandemic will not be the only crisis that we would have seen. There would have been many other crises, and there have been other crises as well, as Shomita had pointed out earlier. Each crisis has to be taken and grabbed with both hands and converted into an opportunity. And thus, here I end my talk. And just before I go, I'll tell you about the introductory courses that we have for other areas of which I was speaking about. And then I hand it over to Mr. Chatterjee again, so that he can start the Q&A session. Thanks very much all for being so patient, if you're still there and if you have not fallen asleep, to have been listening to me on a Sunday afternoon. Thank you.